Hi all, this video is going to be about what is parallel computing. So what is parallel computing? This question takes us to the question of what is supercomputer. So what is supercomputer? Why supercomputers? So before 30 to 40 years back, there are mainly two types of computers. One is supercomputer, the other one is a conventional computer. Supercomputer is employed for high performance computing, where computationally intensive tasks for mainly for numerical simulations of high fidelity physical simulations like weather forecasting, aerospace applications. These conventional computers were employed for day-to-day activities. So you might be imagining that supercomputers would be having a high CPU power and conventional computers having a less CPU power. So in one or the other way, it seems to be right. Yeah, there used to be a situation right from 50s that the CPU power kept increasing for every 2 years as per the Moore's laws. So what Moore's law says is that the number of transistors in the chip will be doubling every 18 months. So almost like every 2 years. But there the limitations came where because of the uh, the the chip the occupational of the chip the keeps decreasing, and the number of transistors, as I mentioned earlier, like it was keep doubling every 2 years. So it gives to the limitation of the heat dissipations, and due to entropy, the power consumptions, all those extra factors made the limitations of increasing the CPU power for a single CPU. So that there the question comes. So instead of employing a one horse, a powerful horse to pull a cart, why not we employ a multiple horses to pull a cart? So similar kind of thinking it went to set up a supercomputers. So instead of setting a single high power CPU to do a powerful computational task, why not we employ multiple CPUs to do a single high power computational task? So there the question came: how do we make an algorithmic setup that the single task has to be distributed to several CPUs so that they could get the same result as if it is been run on a single CPU? So there the came the two things. One is setting up a multiple CPUs in a single system called parallel computers. So the parallel computers are implicitly were termed to be becoming a supercomputers, and algorithm where that high demanding task been distributed along these parallel CP in the parallel computers in multiple CPUs to get the same result as if it's been run on a single CPUs, termed as a parallel computing or parallel computing algorithms. As we know that the architecture, like in 1950s, were not as like what is today's architectures, and moreover, the power of architecture on 1950s, which were considered to be as a supercomputer, were not that any more supercomputer compared to seeing even in a mobile chip, it has a high computational power. So the architecture were kept changing. Computational power of a single CPU were kept changing over these 70 years. But coming to the other terms, the algorithm, the computing, the software employed to do this multiple, to do the single heavy computational task along these multiple computers didn't change as exponentially as similar to the parallel computing architectures. So one is worthwhile would be learning what is parallel computing, what is the parallel computing algorithm being employed since 50s to now. It doesn't change much. So we are learning that technique of parallel computing is worthwhile to understand so that it will be kept in our box for a long time. So this video and the forthcoming videos are going to not introduce the architectures, but rather it's going to introduce what are the concepts for parallel computing. So now the parallel computing or multi-core computing is not anymore to be meant only for supercomputing. Even everyday today task, even the mobile platform is filled with multi-core CPU, like Snapdragon, Qualcomm. It have an 8-core, octa-core, hecta-core, and even if you terms of supercomputers, they also filled with multiple CPUs, even the GPUs. The one of the groundbreaking thing happened in that NVIDIA GPUs. It has a multiple GPU. The architectures might be varying from what I said from NVIDIA or Qualcomm or a supercomputer, but and the concept behind the algorithm is almost similar in all across all these architectures. So one of the main concept of that parallel computing is a vectorization. How do we how uh, so this video will not be more covering of what are the concepts behind this parallel computing, but I'll just give you an overall idea. In this lecture series will be covered based on this content. So I'll just again start with what is supercomputer, why supercomputers in the next videos, and what are the architectures we generally have related to the multi-core, multi-CPU things based on how the memory and the CPUs are uh, constructed, like a shared memory or distributed memory or single instructions or multiple instructions concepts. And also we will be uh, talking about a very important concept of parallel computing called vectorizations, where the tasks are distributed along CPU so that the final output is not disturbed, and how those one of the main concept related to the heavy computational power is related to the matrix computations. Even if in terms of graphics or numerical simulations, whatever it may be, the fundamental core of high performance computer requirement is related to the matrix computation. So the mostly here this video will be talking about how those matrices operations and the computations are distributed along these multiple CPUs to get the same results. So one of the important concepts is vectorizations. Now, how that vectorization happen in loops, and how these algorithms in vector computers like multiple CPUs are employed for matrix vector product, matrix multiplications, and how those can be employed to solve numerical simulation. For numerical simulation, we need some linear solvers, and those linear solvers, one of the primary thing is some decomposition based matrix decomposition based solvers like LU decompositions. And there are some default libraries called LAPAC and BLAS libraries, how those parallelizations have been employed in these BLAS and libraries. The other and the last chapter would be like a specialized architecture called distributed memory architecture, and how those matrix operations are employed in here, like Gaussian eliminations, matrix multiplications, and iterative methods like Jacobi methods, eigen decompositions, how the load balance happens, and all those things will be covered here, which will be very much useful for you even in this present era of automating all these parallel computings in GPUs. But understanding a primary reason behind how those things have happened, how the computer graphics is being employed in GPUs to do a very powerful operations in movies. All those things are based on this parallel computing concepts. Hopefully, we will cover all these things in a series of videos. Hopefully, see you in next videos. Thank you.